Today we're going to solve this double integral that has x's and y's interwoven. All right, let's get into it. First thing that we're going to do is we're going to rewrite our problem because you'll notice that our x's and y's, they're just kind of stacked on top of each other. So it's going to be a little bit easier if we break those apart and we write it as x times 1 over y plus y times 1 over x. It's going to be just give us a little bit of breathing room. Oftentimes the best thing in math to do is rewrite your problem. All right, next thing that we're going to do is let's figure out what we are integrating with respect to first. And we always want to start off with the innermost d, whatever letter we have. In this case, it's a dy. So let's highlight where all our y's are. Notice we have a y in both terms of our expression here, and we're going to be using our first bounds, the 1 to 2, on the integral there. So that's what we are integrating with respect to, which means, right, we're going to start off, our first bit is going to copy paste the outer integral. We are going to leave the x alone. Think of it as a constant at this point, and the antiderivative of 1 over y is going to be natural log of y plus, and now we have the antiderivative of y, so we're going to add 1 to our exponent, divide by our new exponent, and multiply by the 1 over x, which again, this time we're going to leave alone because we're going to think of it as a constant, and we're going to chuck our bounds in there. All right. And you can kind of think of that as a big glob right there. Let's evaluate that before we go any further. Okay, so there's going to be a lot of copy paste here. We have x times natural log of 2 plus 2 squared over 2 times 1 over x minus x times natural log of 1 plus 1 squared over 2 times 1 over x, and then we have a dx on the back side there. So a couple things. First of all, natural log of 1 is equal to 0, so that whole term just disappears completely. Second of all, one of our 2's is going to cancel here, so we're just going to get 2 times 1 over x. And let's rewrite this a couple times so that we get just a little bit of a better sense of what's going on before we do any more integration. It's just going to make our lives easier. So again, we'll rewrite our integral, and that x times the natural log of 2 just follows along. We have plus 2 times 1 over x minus 1/2 times 1 over x dx. Now you'll notice there is a 1 over x in these last two terms. So what we're going to do is we're going to yank that out, and we're going to simplify this even a little bit more. We're just going to copy paste that first part there. Plus, oops, where did this go? There we go. Whew. Okay, we're going to yank out that 1 over x. And once we do that, we're left with 2 minus 1 over 2 dx. And let's just, I'm going to do this one more time. Actually, let's do this on the next page. 2 minus 1/2, so we're going to be left with a 3/2 times 1 over x. And then we're going to be set to integrate with respect to x. So we have x times natural log of 2 minus or plus 3/2 times 1 over x dx. All right, now we can integrate with respect to x. Everything's set up. It's very beautiful. Antiderivative of x, add 1 to our power, divide by our new power. Natural log of 2 is just a constant, so it comes along for the ride. Same with 3/2. Our antiderivative for x is natural log of x, and we are evaluating from 1 to 4. So now we're going to punch that information in. That is going to give us 4 squared over 2 times natural log of 2 plus 3/2 times natural log of 4. And then we are subtracting 1 squared over 2 times natural log of 2 plus 3/2 natural log of 1. All right, again, natural log of 1 is equal to 0, so the second term there just vanishes completely. We're going to do a little bit more information here to just make things a little bit easier here. We're going to do some things to wrap this up, because I know this looks like a natural log of 4, and it's like, well, the natural log of 2's we can pull together, but what about that natural log of 4? We're actually going to pull that in, because if you recall, if you have natural log of a to some power, you can actually bring your power down front, and we're going to use that information there. So let's start off with 4 squared is going to be a 16/2 natural log of 2. And I'm going to rewrite this a couple times. So our second part is 2 squared. And you can see now here's our exponent. We're going to bring that out front in our next step here. Minus 1/2 natural log of 2. So now we get, let's combine these two terms. We'll combine the 16/2 minus 1/2 is going to be 15/2 natural log of 2 plus 2 times 3 over 2 natural log of 2. Our 2's are going to cancel there. Oh, actually, let's leave that as is. We're going to actually erase that just right there, because notice our denominator, I forgot about this. We want to keep that same denominator, because this is going to give us, we'll do this in 2 steps here, 15/2 natural log of 2 plus 6/2 natural log of 2. So this is going to give us 21/2 natural log of 2. And there is our solution. Beautiful, and just one nice little right there. Thank you for listening.